Morning, everybody. Are you ready? Yes. Great. So there's some people coming in. I'll just wait another 30 seconds before I start. Okay, everybody, welcome and good morning. I will give a short talk about ArangoDB today. My name is Jan Steemann. I'm working for a Cologne-based company named Triagens. That is the company behind ArangoDB. And actually, before we dive into the subject, I would like to know from you, who has ever heard of ArangoDB before? So one person. So hopefully this is going to change soon. And yeah, actually, what is ArangoDB? So if you have never heard of it before, I will give a short introduction on it. And ArangoDB actually is a NoSQL database. So there are a lot of NoSQL databases around, as you all know. There are probably around 150 NoSQL databases around at the moment, and they're all different, and they're all not perfect, and ArangoDB is one of them. But ArangoDB is one of those that allows you to use JavaScript in the database, which is kind of special because there's not so many NoSQL databases that allow you to do so. So ArangoDB is a NoSQL database server, and ArangoDB is open source, so you can use it for free, download it for free, inspect the source code. The license is Apache 2.0, so you can use it for all requirements that you have. We're currently, it's still a young project, nobody has ever heard of it, so this is because at the moment we are at version 1.0, and the project is around 1 year old. So compared to some of the other NoSQL databases like MongoDB and CouchDB, we are still relatively new. And ArangoDB itself is written in several languages, so it's written in C, C++, and also JavaScript. So good parts of the server business logic are coded in with JavaScript, actually. And for the JavaScript implementation, when we run JavaScript, we use Google's V8 engine. So that is the same engine that powers Node.js and the Chrome browser. You probably heard of that before. And ArangoDB is it allows you to use the JavaScript not only from the client side, like for all the other databases which allow you to use JavaScript as a client. It allows you to use JavaScript as a client as well, but also inside the server. So you can use JavaScript to code inside ArangoDB. And what does ArangoDB actually do? So ArangoDB is a database and it stores documents. So what actually is a document? A document is nothing else but a set of key value pairs or attribute names and value pairs. And think of a JSON object. So whenever you look at this JSON object here, you can also consider this to be a document. And this is actually what ArangoDB stores. And if you have several of those documents that you want to process within the database, you can put them into something that we name collections. Collections are our equivalent of what tables are in relational databases. So if you organize your documents, you put them in collections. Collections are just more or less names or groups of similar documents. And what types of data can you actually store? Well, you can store JSON. So ArangoDB stores JSON data. Documents are just JSON, and so it makes it easy to use from JavaScript, because in JavaScript you deal with a lot of JSON, and your data is already JSON encoded in most of the times, so you can put it into ArangoDB without any other transformation. You can just store your JSON as it is. And you can employ all the JSON data types, including the arrays and the objects and the nesting stuff, and you can save it just as it is in ArangoDB. And the data that you store, it must be JSON, of course, but apart from that, it's schema-free. So you don't need to define a schema up front, so you don't do something like a create table in another relational databases. You just store the data and that's it. You can store documents with different structures in the same collection, so you don't need to announce that there's a new type of document now. You can put all these documents, and they're all heterogeneous, you can put them in the same collection without telling ArangoDB. So it will happily pick it up. It just needs to be valid JSON. So there is no alter table stuff like that. There's no create table stuff like that. You just store your documents and that's it. So you don't need to care about any sort of schema or schema migrations like you have to in relational databases. And ArangoDB uses a lot of established web standards for the API and the protocols. So ArangoDB offers all the server functionality as an HTTP REST API. So whenever you talk to the database from the outside, you use an HTTP API. And because this is so much, everybody is using HTTP, you can even talk to ArangoDB from your browser. So you can fire up a browser and use ArangoDB from your browser because it answers HTTP queries. And everything that's packaged inside these HTTP queries is normally JSON. So it's really easy to connect to ArangoDB because all you need is a browser for the start. And it's also easy to connect to ArangoDB from JavaScript from a client because it's just HTTP. And inside HTTP, it's JSON. And every JavaScript framework has capabilities to do that and to transfer that sort of data. So it's really easy to connect to. But there's also prefab clients or drivers for a lot of languages like Ruby, PHP. And there's also a Node.js client, which allows you to connect to ArangoDB or use ArangoDB as a backend from your Node.js application. And we also provide a JavaScript-enabled shell ourselves. So there's something like a client tool that we bring with ArangoDB, which is also a JavaScript console. So we can run JavaScript programs in it and connect to ArangoDB and do anything you want to. And it's all JavaScript. So it's more or less a natural JavaScript integration. How do you get your data back from ArangoDB? So you now have put your documents into ArangoDB. What do you do with that, with them then? So ArangoDB supports lots of different query types. The easiest way is you can pick up all your documents that you previously saved by their unique key. So this makes ArangoDB also something like a key value store. So every document is uniquely identified by a key. And you can get it back by that key, obviously. So not very special. But ArangoDB also allows you to run queries like this. So you can provide an example document that you would like to have. And it will look in the database in the collection users for documents that have at least these attributes and gives you all the documents back with that particular shape. And these are already really real examples from what you can do. So this is just JavaScript code, and you can run that JavaScript code from a client or from the ArangoDB shell to get your data back. So it's very easy to use from a JavaScript client. ArangoDB doesn't only allow you to query like this, what you've seen before by a unique key or by an example. You can also index your data if you want to. So a document normally has more than one attribute. It has a lot of attributes. It can have sub-attributes like nested attributes. And ArangoDB allows you to query your data by all of these attributes and sub-attributes. And to make it really fast, you can also index these attributes and sub-attributes. We provide several different index types which are specialized. So we have hash indexes, which allow you to look very fast, do very fast lookups for equality. So to find an exact match, you can use a hash index, which is a fast variant. We also have skip list indexes, which you can use to do equality lookups and range queries. So an example would be give me every document where the age attribute is bigger than 18 or whatever. We also have a special index type named GeoIndex, and we cannot use this index to query coordinates on Mars because it's just all the coordinates that you can put in there are more or less Earth surface coordinates. So you can just use it for Earth coordinates, which should be good enough for most applications because not everybody is sending devices to Mars. And yeah, an example for the GeoIndex query usage is like this. So imagine you have a collection named bars with several types and names of bars in them with geo coordinates. And if you want to look up all the bars in a certain area or around a certain point of interest, you can specify a query like this. So there's a near query which runs on the geo index. You specify the coordinates that you are near, and it will look up all the bars, or here just the first one that's near that point. And that's actually something you do a lot in location-based services. And there's also something similar, like there's not only a near query, there's also a within query which returns all the documents which have coordinates that fall within some radius around a certain point, which makes it really easy to use to do geo queries with ArangoDB. Apart from that, so we had simple document queries, we had geo index queries. ArangoDB also allows you to store references between documents. So far we had just single documents in the database, but you can also connect these documents now, which is something that we name references. And references are just documents themselves in ArangoDB, so that you can query them as regular documents, but they have two endpoints because they connect two documents to other documents. And you can use that to do something like this. For instance, you have two user documents, this one, and they are unrelated. But if you introduce a reference between them, you can store the reference in a special collection. And this reference just connects this document and this connection is directed. And this connection can also have extra attributes, like this one, the type attribute. So all the connections, all the references can carry any extra attributes because they are just documents. And once you've stored that, you can also query that. So for instance, you can query who is connected to Jan, and you can do inbound and outbound queries, so you can actually do something like who knows who, and who refers who, and who recommends what, and do something like this with references. And that's a very simple example, but you can also, of course, do multi-level references. So you can reference from a document to another document and just to another document. So you have something like paths in a graph. So what you can do is, if you use that a lot, you can actually model graphs in ArangoDB with documents and references. So vertices and edges are nothing but documents in our terminology. You just store them in ArangoDB and use some special queries like this one to get the connections of documents. And if you traverse that, obviously this one will just give you the connections to one node or one document, but you can run that in a loop or in a recursive loop and so on, so you can traverse through a graph. And ArangoDB brings some functions to do simple graph traversals, very simple graph traversals, but as graph traversal normally is relatively special or very customized, these prefab functions that we have will not cover all thinkable use cases. So you can write your own traversals if you want to. So you can just write JavaScript in the server, query the documents you want, query the connections you want, and just go on and traverse the graph yourself if you want to. And you can do that by running JavaScript functions, which we'll see in a few seconds. Apart from that, so that these were the predefined query methods that Arango brings. So if all that is insufficient for your needs, ArangoDB also has its own query language, which is able to run very complex queries even. So the query language it has, it allows you to do something like joins. It allows you to do aggregation, subqueries. So all the stuff that SQL does in a relational database is more or less covered by this query language. The disadvantage of using this query language is it's a new language and it's not JavaScript. So you can use that and you can do a lot of things with it, but it's not really JavaScript. But if you have complex queries which you cannot, which are not covered by one of these very simple query methods, you can use this query language, and of course you can use this query string and run that from a JavaScript function, right? So this is also usable from within JavaScript, but it's a different language. You don't need to understand all of these details. It's more or less it's the same as SQL, but with a slightly different syntax, but you can do the same stuff with it. And this should only be used if your requirements are so special that you cannot use one of the other JavaScript-based query functions. And ArangoDB, so what we've seen now is querying and querying from the client. So what you can do with ArangoDB 2 is you can write your own JavaScript code in the database. So at several points, all you need to do is just connect a client to a database, put the data in and get it back out. But that will not modify the data in any sort of sense. What you can do now is, if you have more complex business logic, you can run server-side actions. And what are server-side actions? Server-side actions actually are nothing else but user-defined functions written in JavaScript on the ArangoDB server. And this also makes ArangoDB an application server because, as we've seen, ArangoDB it can answer HTTP requests that are coming. And if you can answer HTTP requests with it and run user-defined functions, then you have an application server. And our way to do it is, we name it this methodology actions. And actions really are nothing but JavaScript functions that you define that answer requests coming from a client. So you can do all of the request handling, all the request validation, all the response processing yourself if you want to, and apply your own business logic inside the database. So if you want to, you can connect from something like Node.js and let Node.js do all the application side of things, but you don't have to. You can directly connect from a client, which can be a browser or anything else, and do all of the processing inside ArangoDB. But that's an option. So ArangoDB gives you the flexibility to do it or to leave it. And actions, they are in ArangoDB, they are just functions that you bind to URLs. So you can tell ArangoDB, if this URL comes in, I want to map the request to this JavaScript function, which I wrote. Or if this URL comes in, and this is something like a wildcard, it should be mapped to this function. And then all the requests coming to these URLs in ArangoDB are handled by your own functions. And one very simple example is, okay, here's a function. It takes a request and a response object, and it simply reads what the user provides in a URL parameter, queries a document from the database based on that URL parameter. So it's a user document, and if that document contains a hash password, you don't want to return that to the client as it is, because you don't need to return a password hash. So delete it from the document and return the sanitized document to the client. This is a very simple example of what you can do. So you can fetch data from your database within an action, process it, and then return something else. And some use cases for this, so you can filter out sensitive data. So you don't allow clients to query your data, your documents directly, but you do something like views do in relational databases. So you pre-process data, filter out something sensitive before responding. You can also, because you have full control over the request that comes in, validate the request and reject it if it's not complying to some policies. You can do privilege checks, do constraint checks and enforce constraints. You can aggregate data from within an action because you can run multiple queries in action and compute an average result or an aggregate result and return this aggregate back to the client. So if you have data-intensive operations like querying 20 different collections, you can do it by running 20 HTTP queries from a client, or you can do it by running one HTTP query from a client to an action and do all of the querying within the action. So you save a lot of network overhead and likely have a performance increase if you use these actions, because the actions, they're executed on the server close to the data. There's no network overhead, whereas if you run them from the client, you have a lot of network traffic and a lot of overhead. So to summarize what we've seen so far, ArangoDB is rather flexible in terms of data modeling because you can use any JSON object and store it. You can use the full nesting within your documents. It doesn't restrict you to something like similar query patterns like a key value store does, because you can query on secondary attributes of documents, so any attribute you can actually query. It allows more complex queries than simple key value stores because you can not only query by key, but you can also by sub-attributes, you can do range queries, you can do geo queries. You also have this special query language that we provide to do very complex queries with joins and aggregates and so on. So apart from that, we also allow you to reference documents, store connections between documents. This allows you to handle graphs within ArangoDB too. So it's very flexible and you're not restricted to some or to one data model. And its API, it uses all the web standards like HTTP, REST, and JSON. So there's no binary protocol as in MongoDB, which just sends cryptic stuff over, which you cannot debug and so on. So it's just HTTP and JSON. So you can trace it with the browser and debug it with the browser. It's very, very simple. And it's also very easy to use from JavaScript, from a JavaScript client. You can use it from a browser directly, but you can also use it from Node.js or any other JavaScript environment because it's just HTTP, and that's what JavaScript is all about. And yeah, you can use it as an application server. If you have your own business logic, you can put that into the database directly if you want to. So it gives you a lot of flexibility. If you want to use that, use it. If you want to have your business logic within Node.js or anything else, do that. That's fine. But you have the choice. And yeah, it's up to you whether you want to extend the server functionality with your own code or not. But ArangoDB will give you the choice to do so. And actually, that's already the end of my talk. So I tried to hurry through all of the slides. So I hope I could gain some attraction for ArangoDB now, and I hope you're all interested in trying it out. There is some websites or some, yeah, if you want to try it out, we have a website where you can look at all the information about the ArangoDB server. We have a GitHub source repository if you want to compile it from source. We have predefined builds for Homebrew and for a lot of Linux distributions. Windows version is currently under development. You can follow us on Twitter and use our Google group to ask questions, and we are happy to help if you should have any. So try it out if you want to. If you want to use JavaScript in a database, why not? Start today and give it a try. And apart from that, that's it. So if you should have any questions, please ask. We can do it now until time's over. And I'll be also available after the talk. So you were first, I think.
Thank you. You have talked several times about using ArangoDB with Node.js.
Yes.
So my question is, what is the reason for using ArangoDB in this case? Why not using simply Node.js? And what brings ArangoDB using this architecture?
Yeah, so ArangoDB is a database, and Node.js is more or less a web and application server. So if you want to store your data anywhere, you need a database, and you can use ArangoDB as a backend. And the problem with most backends is you can store your data in them, fine, but you need to fall back to other languages if you want to administer the database or do something with the data. In ArangoDB, it's all JavaScript, so it's natural to pick because you don't have to leave the JavaScript world. You can administer the database using JavaScript. You can modify your data in the database with JavaScript. That's fine. You cannot do this with all of the other databases. And yeah, Node.js itself is very good, but it doesn't have a data store. So you need to pick a data store to persist your data, I think. If that, I hope this answers your question. There's another one.
On your roadmap, you're showing that the version 2.0 is going to have the master replication.
Yes.
And the sharding.
Yes.
And it lists end of 2012 for that. How are your schedule looking?
Yeah, so at the moment we are developing the 1.2 version. 1.2 will contain MVCC and asset transactions, which you can also define in JavaScript or with, that wasn't me, with JavaScript code. We also will implement something like triggers. That means functions that will be executed when you insert or update documents. And there's synchronous and asynchronous replication, which will make ArangoDB work like a cluster or a cluster database. That's on the roadmap for the version 2.0, as you said. And I cannot tell you an exact release date for that. It will be next year, but I cannot tell if it's spring or summer. It will be something like that. But this one will come first, and replication will come after that. So the roadmap on our website is probably not fully up to date with the timeline. Yeah.
Do you have any access rights in the database to determine which users can access which data, or is that something that you would have to build on an additional tier in front of the database?
There is currently HTTP authentication, which so you have users that you can put into a collection and allow them access to the database or not, and reject everyone that's unauthenticated. We plan to implement more complex privileges based on that. We have made the experience that a lot of people don't care about privileges at all. So a lot of databases have privilege systems, but they are not even used in many cases. We plan to do something about that. So you can use privileges if you want to, but in an upcoming version. At the moment, we have HTTP authentication only. But if you're authenticated, then you can access the full database, which is obviously not covering all the use cases, but will be fixed.
I have two questions. The first one is to get a document. You said that there was two main solutions. The first one with the unique ID of the document, but isn't auto-generated when you save a document?
At the moment, it's auto-generating, but that's we changed that. So the version that's currently in development is already changed that. So you can auto-generate documents or document keys, or you can let the users define these keys themselves. And we also implement key generators, so you can use something like auto-increment or generate session IDs or something like that automatically. So you can define how the keys come in.
Okay. Yeah. And so the second one was the application server is well powered by Node.js, or is it another solution?
No, it's inside ArangoDB itself. So it's powered by Google V8, the engine. That's the JavaScript engine, and it's actually the same engine that Node.js uses. But apart from that, it has nothing to do with Node.js. Okay. So it's completely a separate product. It can be used together with Node.js, but you don't have to.
Okay, thank you very much.
Yep. You're welcome.
ArangoDB is both a database and also an application server. Don't you think it's too much for only one product?
Well, I wouldn't say so, because it depends how you use it. You can use it as a database only, then don't care about the application server part. Just use it as a database and then you're done. If you want to, you can use it as an application server, but actually what I would suggest using is using the application server part for just specific actions, like very complex data operations, which would otherwise require you to do a lot of queries over the network. Like, yeah, if you have a user object that refers to friends, you don't want to query from a client the user and all of the friends subsequently, because then you would have probably 100 requests. If you can do that on the server, that's even better. So use that part of the application server, write some specific function that does all that, and returns an aggregate result. Then you will increase the performance, reduce the overhead, and use the application server part just for where it's necessary. But it's up to you. So you can use it as a simple standalone database if you want to. Okay, so time's up. No more questions here. So if anyone has additional questions, just let me know. I'll be here until the end of the conference. Thank you. Thanks.